Rice is a staple food of more than 60% of the world's population. Maximum area under rice is in Asia. Among rice-growing countries, India has the largest area of about 40.2 million hectares, followed by China and Bangladesh. Rice is India's predominant crop and is the staple food for people of the eastern and southern parts of India. Take name of crop, rice 2. Botanical name, Oryza sativa L. Teen. Family, Persei 4. Chromosome No. 2n equals 24-5. Center of origin, Orissa and Southeast Asia 6. Mode of pollination, self-pollination 7. Outcrossing pratishat, 0 to 3% with an average 0.5%. Isolation distance, 3 meters for breeder or foundation seed. Related species. Cultivated species of rice, A. Asian rice, Oryza sativa L. It is predominant species which has spread to different part of world. B. African rice, Oryza glaberrima L. It is still confined to tropical Africa. The Asian rice grouped into 3 ecological forms based on morphological and physiological characteristics and geographical adaptation. 1. Indica, grown in tropical climate, India, Sri Lanka, China, Thailand, Malaysia, Taiwan 2. Japonica, temperate climate, Japan, Korea 3. Javanica, intermediate between Indica and Japonica, distinguishing characteristics of 3 ecological forms of rice. Type of cultivation in rice, 1. Upland rice 2. Irrigated flooded rice 3. Rainfed or lowland rice 4. Deep water and floating rice 5. Vegetatively propagated rice breeding objectives. 1. Higher yield. 2. Adaptability and stability. 3. Early maturity. 4. Lodging resistance. 5. Disease and pest resistance. 6. Grain quality. A. Shape, size and translucency of grain. B. Texture of endosperm and quality of starch. C. Aroma or cooking quality. Basmati type. D. Milling quality. A. Seed dormancy. 7. Breeding for improved nutritional quality. Golden rice. 8. Honest. Floral biology. 1. The rice inflorescence is apanical that bears single-flowered spikelets, having 6 stamens instead of 3 in other cereals. Though the flower is surrounded by the lemma, polea and glooms. 10. The blooming of rice normally occurs between 8 am to 11 pm. The flowers in a single panicle bloom over a period of 7 to 10 days, but most of the flowers bloom between 2nd and 4th days after emergence of the panicle from boot leaf. Blooming of the spikelet starts at the top of the panicle and proceeds downwards. Chart. Pollen shedding begins at the time of flower opens with blooming of the spikelet. Character Indica, Japonica, Javanica. Thin and short, dense or long 5. Day temperature, high solar radiation and low night temperature promote panicle production. Fig. Rice panicle showing its branching pattern or attachment of spikelets. Fig. Rice open spikelet. Fig. Rice closed spikelet and open spikelet. Spikelets. The spikelets are single flowered, each with a short stalk. Glooms. There are 2 small glooms at the base of each spikelet. Floret. The floret consists of the lemma, the polea, 2 locules, the androecium and the gynoecium. Lemma. The lemma is large and hairy. It is on 5-nerved structure. Polea. The polea is hairy, smaller than the lemma and is present opposite to it. It is 3-nerved structure. After maturity, the lemma, the polea and the glooms remain attached on the seed as a cover called husk. Flower. The flower is bisexual, zygomorphic and bracteate. Main axis secondary branch spikelets tertiary branch. Androecium. The androecium consists of 6 stamens arranged in 2 whorls whose filaments are short in earlier stage. The filament elongates immediately after floret opening and brings anther to the level of stigma. The total number of pollen grains per anther is reported to be directly correlated with the anther size. Normally 2 to 3 pollen grains are required per stigma to fertilize one egg cell. Gynoecium. The gynoecium is monocarpellary and has a superior ovary, with 2 feathery stigmas on a style. Receptivity of stigma is maximum during the first 3 days after opening of spikelet and then is gradually lost after 7 days. Stigma exertion, large stigmatic area and its receptivity, all play a major role in determining high seed set in CMS parent. Anthesis and mode of pollination. The flower may open from 7 am to 4 pm depending upon the season. Most of the flowers start opening at the apex and the flowering proceed downward in the panicle, but in the branches it is not strictly so. In rice 3 types of pollination are possible. The usual process is that the anther burst as they emerge and pollinate the stigma, leading to self-pollination. The anthers burst open and pollination takes place before blossoming, generally at high temperature and under low humidity, leading to self-pollination. Under certain temperature and humidity conditions, the anthers may emerge from the flower without bursting and such flower is generally cross-pollinated. Emasculation. Several methods have been used for emasculating rice. 8 Standard method. This is most widely used method of emasculation in rice. Remove all the immature and mature spikelets from the panicle. Separate the glooms with the help of a pair of forceps and gently remove all the 6 stamens. To speed up the emasculation, suction may be used. Emasculation is generally performed in the evening and the pollination is done next morning. After emasculation, cover the female with butter paper bags. Tagging is also done. B. Hot water treatment. This method of emasculation is commonly used in Japan. The immature spikelets are cut off. The panicles are dipped in hot water containing constant temperature of 42 to 44 C for 5 to 10 minutes. Pollination. Collect the pollens just before anther dehiscence. To apply pollens, the anthers from the derived male parents are shaken over the emasculated florets. If pollens are not available in plenty, then repeat the above process. After pollination, bagged and labeled it. If 2 panicles on the same plant are to be pollinated by the same male parent, they are brought together by wrapping the 2 clumps and are tied with a clip. The other bag is also placed over both panicles. Crossing technique. Panicles in the 2nd and 3rd days of blooming are selected for emasculation. Open and immature florets are removed. Then the panicle is immersed in water having temperature 42 to 44 degrees Celsius for 5 to 10 minutes. Pollinate the emasculated panicle and then bagged and labeled it. Breeding methods. Genetic improvement of rice can be achieved by A. Introduction. Pure line selection, bulk, backcross and pedigree methods. A. Introduction. All the IRRI rice varieties from R8 to R72. Other examples are Basmati from Punjab, Ponni Masuri from Malaysia, Ponmani from Orissa. Though. Pure line selection. 3. Hybridization and selection. A. Pedigree method. I. Intervarietal. E. Interracial Japonica x Indica cross A DT27, Noran 10 x Geb 24, Ponni Mashuri Taichung 65 x Mi 80 E. Interspecific crosses Co 31 O. Perennis x Geb 24, Drought resistance. R34 complex cross, one of the parent is O. Nivara B. Back cross method of breeding. B. Special methods, mutation breeding, heterosis breeding and distance hybridization. Chart. Mutation breeding. Mutation breeding has played significant role in the rice improvement. A. Spontaneous mutation Gep24, ADT41 dwarf mutant of Basmati 370. B. Induced mutation, Jagannath rice from Orissa, Parbhani from Maharashtra. 5. Heterosis breeding, rice hybrids. APHR1 A580225AX Vajram APHR2 A62829AXMTU9992 KRH1 A580225AX A9761110 A CORH2 A580225AX C20R. Idotype breeding. Physiological features of crop idotype are expected to differ for irrigated cultivation or rain-fed cultivation. The concept of plant type was introduced in rice breeding by Jennings in 1964, while the term idotype was coined by Donald in 1968. Idotype breeding, aimed at modifying plant architecture, is also a time-tested strategy to increase yield potential. Selection for short-statured cereals such as rice and wheat resulted in a doubling of their yield potential. Hybrid rice. Heterosis in rice was reported by Jones in USA as early in 1926 and Ramaya in 1933. But the research work on hybrid rice was initiated in 1964 in China by Yuan Longping, father of hybrid rice. The identification of the bar-type cytoplasmic male sterility in 1970 was a breakthrough in hybrid rice breeding. In 1971, China accepted hybrid rice research as a national cooperative project, and in the year 1976, hybrid rice became a reality in China, for the first time in the world, by the release of commercial rice hybrids. Since then, many commercial rice hybrids were released in countries like Vietnam, Korea. Besides these countries, research on hybrid rice is progressing in countries like Philippines, Indonesia, Malaysia, Thailand, United States, Egypt, Colombia and Brazil. Although research on the commercial utilization of heterosis in rice has made tremendous gains during the last 20 years, it is still in its infancy stage because the high yield potential of hybrid rice has not been fully tapped yet, and hence various approaches are adopted in major rice growing countries of the world to maximize the yield potential. Advancements of hybrid rice production. Breeding techniques for developing hybrid rice involve the following. A 3-line method or CGMS system, the system involving 3 lines viz. Cytoplasmic, Genetic male sterile line A, maintainer line B, and restorer line R is the most commonly used method in China and outside. CMS system like Wa, Ga Gambiaka Dikdisi D8 dwarf wild rice, BTC, Chinsura Boro 2, and IP, Edo Paddy 6, has been identified. Long experience had CMS system involving sporophytic and gametophytic male sterility is an effective way of developing hybrid rices and will continue to play an important role in the next decade. However, there are some constraints and problems in such a system. The most serious is that yields of existing hybrid rice varieties, including newly developed ones, have stagnated. Yuan, 1994. They have already reached their yield plateau and are unable to increase the yield potential through this approach, and hence new methods and materials were adopted. In this regard, 2-line hybrids are promising ones to raise the yield ceiling in hybrid rice. B. 2-line method of rice breeding. 2. Application of gameticides. 3. Use of CMS. 4. Use of GMS. 5. Use of environmentally induced genetic male sterility EGMS. EGMS lines are made use of with in rice. EGMS system is commonly used. Developing hybrid rice varieties with these system has the following advantages over the classical CMS system. At least effect due to sterile cytoplasm. In 1991, China had released hybrid combinations using this approach, and some of these combinations out-yielded the best existing hybrids by 10 to 20%. Work is progressing in India and International Rice Research Institute in Philippines to identify best-suited rice hybrids through this approach for commercial exploitation. TGMS system is considered useful in tropical subtropical regions. GMS system is useful in temperate regions. Other possible approaches to develop two-line hybrid breeding system includes identification of a genic male sterility system which would revert to male fertility in response to application of growth regulators and also the chemical induction of male sterility. C. One-line method of rice breeding. Rice hybrids can be developed and popularized through the following concepts: vegetative propagation, micropropagation, antherculture. Hybrids apomictic lines. Among the above, apomictic lines and anthercultured materials will be economical for large-scale cultivation. Tissue culture, particularly antherculture, has been utilized in rice improvement by China and also developed several varieties. Been developed by IRRI. The DGOVU gene has been used as source of dwarfing gene in evolving semi-dwarf rice varieties. Improved varieties: GR3, GR4, GR5, GR103, GR6, GR7, Ambika, Gurjari and Jaya hybrid varieties: APHR1, APHR2, COHR1, KRH1, KRH2, DRRH1. CNHR3, PHB71, MPH516, MPH517, MPH518, PRS1 and VRH4. Research stations. A. International Rice Research Institute, IRRI, Los Baños, Laguna, Philippines. B. National Central Rice Research Institute, CRRI, Cuttack, Orissa, DRR, Directorate of Rice Research, Hyderabad. A. P. C. State level. Main Rice Research Station, AAU, Navagam, Kheda, Gujarat. Tarankan,